Right now, in laboratories at UCLA, Stanford, MIT, and the University at Buffalo, scientists have proven that a device costing approximately $15 in household materials can cool a space below the outside air temperature with no electricity, no compressor, and no refrigerant. The device has no moving parts. It requires no maintenance. It works day and night. And you cannot buy one anywhere on Earth. Not at Home Depot, not at Lowe's, not on Amazon. The technology exploits a quirk of physics that has existed since the atmosphere first formed around this planet. Yet it sits in published research papers, while the global HVAC industry quietly generates $130 billion every single year. Every dollar you do not spend on electricity is a dollar. The utility and cooling industry does not earn. That is not a conspiracy theory. That is a business model. And by the end of this, you will understand exactly how this works, how to build one yourself, and why the most powerful cooling technology on the planet has been kept off store shelves. To understand how this device works, you need to understand something strange about Earth's atmosphere. Our atmosphere blocks most infrared radiation. Heat radiating off the ground, off buildings, off your body, gets absorbed by water vapor and carbon dioxide and bounces back down, which is why nights stay warm and why the greenhouse effect works the way it does. But there is a gap. Between 8 and 13 microns on the infrared spectrum, there is a transparency window, a range of wavelengths where the atmosphere is essentially invisible. Heat radiation at those specific wavelengths passes straight through the atmosphere, through the clouds, through everything, and escapes directly into the cold void of outer space. And outer space sits at roughly 3 Kelvin, which is negative 270 degrees Celsius. That is the coldest heat sink in the universe, and it is sitting directly above your roof every hour of every day. In 2020, UCLA engineers Xin Huang, Jyotirmoy Mandal, and Aswath Raman published a method so simple it almost sounds like a joke. They took 2 layers of common Scotch tape and applied them to ordinary aluminum foil. That was the device. The acrylic adhesive and plastic film in standard household tape naturally absorb and re-emit heat at exactly the right infrared wavelengths, right in that 8 to 13 micron atmospheric window. The aluminum underneath reflects incoming sunlight away, so the surface does not heat up. Together, these 2 materials form what physicists call a selective emitter, a surface that reflects solar energy arriving from the sun and radiates thermal energy out through the atmosphere and into space, all from materials sitting in your kitchen drawer right now. The performance numbers are not theoretical, they were measured. At night, the aluminum foil and tape design achieves 7 degrees Celsius below ambient temperature. That is 12.6 degrees Fahrenheit cooler than the surrounding air, with 0 energy input. Adding a polyethylene convection shield, essentially a layer of plastic wrap stretched over the top to stop warm air from mixing with the cooled surface, pushes nighttime cooling to 11 degrees Celsius below ambient, which is nearly 20 degrees Fahrenheit. During the daytime, a silver-coated version still achieves 2 to 3 degrees below ambient because sunlight adds heat that fights the cooling effect, but it still wins. The surface still gets colder than the air around it using nothing but physics. And these UCLA results are not an outlier. At Stanford University, Professor Shanhui Fan's lab built a multi-layer photonic nanostructure, a more sophisticated engineered surface that achieved 5 degrees Celsius below ambient temperature under direct midday sunlight. That research was published in Nature, one of the most prestigious scientific journals on the planet. Fan's team then built a fluid-coupled version that cooled circulating water 3 to 5 degrees Celsius below air temperature continuously over 3 days of outdoor testing. At the University at Buffalo, Chao Qiang-gan developed a cheap polymer aluminum film placed inside a tapered foam box that delivered 6 degrees Celsius of cooling during the day and 11 degrees at night. And at MIT, Researchers built a hybrid system combining radiative cooling with evaporative cooling and aerogel insulation that achieved 9.3 degrees Celsius, or 19 degrees Fahrenheit, below ambient. That MIT system extended food shelf life by 40% in humid climates and tripled it in dry climates, all without a single watt of electricity. So here is how you build one for about $15. You need a roll of Scotch tape, aluminum foil, rigid foam insulation board, and optionally some polyethylene film like plastic wrap or a section of bubble wrap. First, build a shallow box from the foam board. Roughly 2 feet by 2 feet works well. Line the bottom with aluminum foil, shiny side up. Then apply 2 smooth layers of tape over the entire foil surface. That tape-on foil combination is your selective emitter, the component that does the actual cooling. If you want better performance, stretch a layer of polyethylene film across the top of the box as a convection shield, which prevents warm ambient air from settling onto the cold surface and erasing your temperature drop. Then point the open face of the box at the sky. It needs a clear view of the atmosphere, not aimed at a wall, a tree, or a neighboring building. Any object in the line of sight radiates its own heat back at your surface and kills the effect. Air or water placed in contact with the cooled surface drops in temperature passively, continuously, with zero energy input. That is it. That is the entire device. But radiative sky cooling is not the only passive technology that has been proven and buried. There is a separate but related concept that uses the Earth itself as a cooling medium. 6 to 8 feet below the surface, the ground stays at roughly 55 degrees Fahrenheit year-round, regardless of what is happening above. At Oak Ridge National Laboratory in Tennessee, scientists monitored ground temperatures for decades and confirmed that below 6 to 10 feet, soil maintains a temperature equal to the local annual mean air temperature plus 1 to 2 degrees. In Chicago, that means 55 degrees year-round. In Atlanta, 62. In Denver, 58. In Phoenix, 67. In Minneapolis, 52. Burying 50 to 100 feet of PVC pipe and drawing air through it with a small fan produces air that exits 10 to 20 degrees Fahrenheit cooler than the outside temperature. Engineers measure cooling efficiency using something called the coefficient of performance, which compares cooling output to energy input. A conventional air conditioner scores between 2.5 and 3.5. Thermal labyrinths, measured across 47 installations worldwide, achieve an average coefficient of performance of 28.7. That is not a typo. They deliver nearly 30 units of cooling for every 1 unit of electricity consumed by the fan, because the Earth is doing all of the work. This is not new knowledge. Ancient Persians built structures called yakhchals in the city of Yazd, precision-engineered cooling facilities rising 60 feet high, with walls 6 feet thick, that maintained interior temperatures of 25 to 30 degrees Fahrenheit through summers exceeding 115 degrees outside. They made ice in the desert, without electricity, without refrigerants, without anything the modern HVAC industry sells. The Passive House Institute in Darmstadt, Germany, has monitored 847 residential earth tube installations since 2005, and they deliver an average cooling capacity of 3.2 kilowatts while reducing mechanical cooling demand by 89%. At the Allgemeines Krankenhaus Hospital in Vienna, an earth tube system has provided 450 kilowatts of cooling to critical care units since 1994. That is 30 years of continuous operation, keeping hospital patients alive, with cleaning required only every 5 to 7 years. So why is none of this in your home? There is no evidence of an HVAC industry conspiracy meeting in a dark room somewhere. The truth is more structural and in some ways more troubling. A $15 DIY panel, or a one-time earth tube installation, generates 0 ongoing service contracts, 0 filter replacement sales, and 0 monthly energy bills. The $130 billion global HVAC industry has no financial incentive to promote a technology that eliminates the customer relationship entirely. The Air Conditioning, Heating, and Refrigeration Institute spent $47.3 million on political activities in 2022 alone. That money shapes codes, standards, and what technologies get legitimized. In 2019, ASHRAE Technical Committee 6.8 rejected a proposal to create a performance pathway for earth tube systems. Their stated reason was insufficient domestic performance data. They ignored 3 decades of European documentation from hundreds of monitored installations. An analysis of that committee's membership revealed that 67% came from HVAC manufacturers. The people deciding which technologies get official approval are the same people whose products get replaced by those technologies. Building codes and standards in the United States are written entirely around mechanical HVAC systems. There is no provision for earth contact air handling. This means it is literally impossible for builders to specify earth tube systems or for building inspectors to approve them, not because they do not work, but because the paperwork does not exist. The International Energy Conservation Code provides 0 compliance credit for passive earth cooling. A builder who installs a system that eliminates the need for air conditioning receives exactly the same efficiency rating as a builder who installs nothing at all. Sky Cool Systems, a Stanford spin-off founded by Shanhui Fan's research team, is the only real commercial player attempting to bring radiative cooling panels to market. They have completed roughly 30 installations, but there is no product on any shelf in any store that a homeowner can buy and install this weekend. By 1980, fewer than 3% of American architecture programs taught passive cooling strategies. The technology was not disproven. It was systematically removed from professional memory. Contractors today have never heard of thermal labyrinths because their licensing exams never mention them, and building inspectors cannot approve what their training never covered. The stakes of this gap between what science has proven and what the market offers are enormous and growing. Global cooling demand is projected to triple by 2050. Air conditioning already accounts for roughly 10% of global electricity consumption. Passive radiative cooling requires 0 energy, produces 0 greenhouse gas emissions, uses 0 water, and needs 0 refrigerants, including the hydrofluorocarbons that are themselves potent greenhouse gases thousands of times worse than carbon dioxide. Even used as a supplement rather than a replacement, pre-cooling intake air before it reaches a conventional AC unit could cut energy consumption by 20 to 40%. The technology is real. It is peer-reviewed. It is published in Nature, Cell Reports Physical Science, and the Journal of Photonics for Energy. German building code already provides efficiency credits for earth tube integration. Austrian national building standards require thermal labyrinth analysis for any structure exceeding 1,000 square meters. A 15-year longitudinal study from ETH Zurich found 0 degradation in earth tube system performance over the entire monitoring period. 0. The physics is settled. The materials cost less than lunch. The reason you do not have a radiative cooling panel on your roof or an earth tube under your yard is not that the science failed. It is that no one makes money when you stop paying for air conditioning. Every dollar you do not spend on electricity is a dollar the utility industry does not earn, a dollar the HVAC manufacturer does not collect, and a dollar the service contractor does not bill. The Earth has been cooling itself for 4.5 billion years. The atmosphere has had that transparency window since before humans existed. The ancient Persians figured this out with mud brick and physics. The only thing standing between you and free cooling is an economic system that cannot profit from a solution that costs $15 and lasts forever.